Done. Okay, so I said tropical cyclone. We were discussing tropical cyclone. Some of the aspects of tropical cyclone which we have to deal is the first one. Just in 5 minutes, I'll talk about this. That is about the naming of the cyclone. Okay. Yesterday I said once one link in the group, once one I would say one article on the naming procedure, how the naming is done, and many of you must be knowing about the naming procedure. Okay. So there are some criteria laid down by a committee of Nations that is part of ISCAP, United Nations ISCAP. Okay. So United Nations Economic and Social Commission for Asia Pacific. Center for one center where we have group of nations adopting some common parameters for naming the cyclone, especially in the Asia Pacific region. And in the year 2000, 8 countries came together. India was also part of it. Like you have India, you have Bangladesh. Okay. Bangladesh, you have Sri Lanka. Okay. You have Thailand, Myanmar. So these were 8 countries here. In 2018, 5 more countries joined, and they were mostly Southwest Asian countries like Saudi Arabia, Oman, Yemen, UAE. Right? These countries became part of this CAP. Okay, so now you have 13 countries, total 13 countries. Okay, and they name the cyclone on rotational basis. Rotational basis. And how that is done? The name of the country is alphabetically arranged. Okay, alphabetically. That means the first country would be Bangladesh. And then you have C, D, E, F, G, H, O, N, E. We have India here. Are you getting my point? Like this. So if Bangladesh has named this time one cyclone, then the next country which is going to name the cyclone would be India. Okay. Like the cyclone Biparjoy was named by Bangladesh. Okay. Bangladesh in the year 2023 in the June month, and one more cyclone came in October, and that was named by India. That was called as Tej. Okay, this is your Biparjoy. So this is how the naming is done on rotational basis, right? And till 2020, 169 names have been proposed by these 13 countries. Okay, 169 names. That means 13 into 13. That means each country have named 13 times and said, and till 2020 you have 169 names given by those 13 members here. So all members have given equal number of names for the tropical cyclone. Right? Now coming to the parameters, what are the conditions or parameters used? Conditions or parameters. Okay. The first is the name should be apolitical. Okay. The name should be non-religious. The name should be I would say it should be it should not be gender biased. That means it should be neutral to gender. Okay. It should not be after the name of any political figure. Okay. All those criteria are there in the first point itself. Second says whatever name is given, the name should not have more than 8 letters. Okay, 8 letters से ज़्यादा नाम नहीं होगा कोई भी cyclone. Okay, that would be maximum 8 letters. Right. The country which is going to name the cyclone should also provide a voice-over clip. Voice-over. That means how to pronounce that particular name. Like if India has named a cyclone, then the country has to provide a voice clip to correctly pronounce the name by other countries. Okay. Then it says that once a name has been given to a cyclone in the North Indian Ocean, right, North Indian Ocean, that particular name will have one time, right, one time life. That means the name cannot be repeated again. Okay, the name cannot be repeated again. Are you getting my point? It also says that the name should be chosen in such a manner that it does not hurt the feeling of any community in the world, right? Any community. Like if I give you a chance to name a cyclone, right? Then you would be saying that okay, the name of the cyclone is Haring. Okay, now that is not right, not acceptable. Why? Because that may affect also, right, or that may that may hurt the feeling of any particular community. Okay, that may be comfortable to you but not comfortable to other community. Okay. This is I mean these are the sort of parameter or I would say the conditions laid down for naming of the cyclone. Just keep in mind it is on rotational basis, right? So last cyclone which has been named named by a country, we say Saudi Arabia. Saudi Arabia was the last country, okay? And now if you have again a cyclone, obviously which is expected in summer month, right? So we'll have after South Africa, after Saudi Arabia, whatever arrangement we have for the country, like you have Sri Lanka also. So SS, right? SS के बाद कौन आएगा? कौन आएगा? Obviously now it would be the term of Thailand, right? अब Thailand इसको name करने वाला, ठीक है? This is how the naming is done. Now coming to the second, again one minor discussion here that is related to the relationship between the marine heat wave and tropical cyclone. Again you have a report on that and I have shared that image in the group. So marine heat wave. Marine heat wave and tropical cyclone. So you must have gone through the article. There are some crux point I am going to highlight here. So first thing, we made the study, or this phenomena was reported during the occurrence of one cyclone named Amphan, right? And this cyclone was categorized into super cyclone. So it was in first category, right? It was in the first category initially, and within 24 hours, the cyclone was categorized into the fifth category, the most severe one. That is your super cyclone. Okay. Why it happened? Right? Why it happened? That was related to one abnormal phenomena. Right? Abnormal phenomena on the surface of water. We call it as marine heat wave. Marine heat wave. That means abnormal increase in the surface temperature of water by around 2.5 degrees Celsius. Abnormal increase. Okay? Abnormal. So this is abnormal increase in the surface temperature of water by 2.5 degrees Celsius, and you know that this tropical cyclone is an atmospheric phenomenon, whereas marine heat wave is an oceanic phenomenon, right? When these two coupled together, right, when you have coupling of these two phenomena, that gives more and more energy to the atmospheric phenomena, that is the tropical cyclone, and ultimately the cyclone becomes monstrous. Okay. So this abnormal increase was observed. That means the temperature increase was observed over the water surface on which the cyclone Amphan was evolving, and it was found that it is abnormally high by around 2.5 degrees Celsius, and it was found that it is mainly due to anthropogenic factor. Why abnormal increase happened? That was because of anthropogenic factor. That means more and more anthropogenic activities are adding carbon dioxide into the atmosphere, and it is now confirmed by the report that 90% of the carbon dioxide which is released by anthropogenic activity in the atmosphere is absorbed by the water body, right? And you know that carbon dioxide is a heat trapping gas. Okay. So when water bodies absorb carbon dioxide, carbon dioxide released in the atmosphere due to anthropogenic activity, that particular proportion, that means the 90% of that emission is absorbed by the water body, and in the process the water body is heat up. Okay, in the process the water body is heat up. So when you have a water body, and more absorption is going on, and you have increase in the surface temperature of the water body. This water body lie in the path of the cyclone. Just imagine that you have a cyclone developed here, right? And now this cyclone is moving over it is moving over the water body. Okay. If the surface temperature of that water body is very high, what will happen? That will lead to faster rate of evaporation. More and more evaporation means the wind which is coming from all direction towards the cyclone, they will be carrying moisture, and that moisture will be supplied to the system, right? And you know that tropical cyclones are mainly sustained by latent heat of condensation. Larger the amount of moisture vapor supplied to or water vapor supplied to the tropical cyclone, right? They would become more and more energetic, more and more lethal, more and more dangerous, and slowly, gradually, they will develop into the severest of the storm, right? The severest of the storm, we call them as super cyclone. So it was found that the cyclone Amphan is a normal storm. It was in first category, and within 24 hours, what happened? It was recategorized, and it was brought into the fifth category, right? That is mainly because of the underneath surface, right? The underneath surface on which the cyclone is moving is having movement of what? Movement of heat wave. What is that heat wave? Marine heat wave. Okay. That means the waves which are flowing over the water body, they are very warm, which is above normal, and that is leading to supply of more and more moisture to the system, and the system becomes monstrous. Okay. This observation was conducted in 2019 also. The report says that there was a cyclone named Funny. That Funny cyclone existed for 7 days, whereas Amphan existed only for 5 days. Right? Funny could not develop into super cyclone. Okay, it was a severe storm only, third category. Right? It could not evolve into a super cyclone. which only means that the under track, that is the track upon which the cyclone is moving. You know that these are your migratory system, right? These are your secondary wind system. So they migrate from one place to the other, and if the underneath surface is having abnormal high temperature, ultimately that will give more and more strength, more and more energy to the tropical cyclone, and ultimately they become large. Okay, they become highly dangerous. Right. This is the role we have of marine heat wave and the relationship between marine heat wave and the tropical cyclone. So keep in mind that marine heat wave is a oceanic phenomenon. Keep in mind, oceanic phenomenon that is related to the water body, whereas the tropical cyclone, we all know that they are atmospheric phenomena. When we have a coupling of these two phenomena, that leads to the emergence of the severest of the storm, right? We call them as super cyclone. Okay? ये तो हम लोगों ने पढ़ा हुआ ना, tropical cyclone, they are atmospheric phenomena, right? And if that atmospheric phenomena is having coupling with, right, if it gets combined with the marine heat wave, that is a oceanic phenomenon. That means movement of warm water over the surface, right? Warm water over the surface, and upon that warm surface you have once again migratory atmospheric circulation. That is your tropical cyclone. If it happens, then in that case it will become very it will become mature. It will develop into a monstrous system. Okay. बात समझ में आ रहा है? तो रिपोर्ट को आप पढ़ेंगे तो आपको पता चलेगा कि रिपोर्ट ने बोला कि 24 घंटे के अंदर जो अम्फन है उसका कैटेगरी 1 से कैटेगरी 5 होगा, ठीक है ना? दूसरा साइक्लोन भी हो रहा है, बट they are not evolving into super cyclone. Why? Because there was missing heat wave, right? Heat wave नहीं है. तो अगर इस ट्रैक पे चल रहे नीचे अगर हीट वेव चल रहा है, जो मरीन हीट वेव, okay, मरीन हीट वेव, and you have this moving cyclone over the water. So ultimately, more and more energy, more and more moisture supply, and we know the role of latent heat of condenses. Okay? So this is the relationship we have between marine heat wave and the tropical cyclone. So that completes our coverage on the tropical cyclone. Keep in mind the differences we have between tropical and temperate cyclones. Sometimes they ask you to compare and contrast tropical and temperate cyclones. So you have many points. You have to talk about 3-4 points only, but give reasoning behind that. Okay, don't highlight the facts only. If you have written 2-3 points, that is more than enough. But ensure that you have reasoning behind that. Why we have such similarities and why we have those differences. This point clear. Now coming to one last circulation here, I'm just going to highlight in brief about the tertiary wind system. Tertiary wind, also called as local winds. And I told you that you have to cover this by yourself. The point which I want to discuss here, that in some of the sources you will find this local wind classified into two categories. That is periodic wind and some manifestation of periodic winds are land and sea bridges, mountain and valley bridges. Others are your non-periodic winds. That means they are not regular, non-periodic. They are categorized into two groups: hot winds and cold winds. Some of the prominent hot winds are They are Pond, Chinook, Sirocco and Harmattan. Some important cold winds here. You have Mitra, Bora, Blizzard, so these are some hot and cold wind. Yesterday I said one file related to देखा होगा आपने hot winds and cold winds. I said that for you just go for one reading only, one time reading. Okay, it is not clear. I said that because I found that the material which is given to you is not sufficient. Okay, so that is why I have given you additional reading on that. Coming to this classification first. You can see here the classification, that is the local winds classified into two categories, periodic and non-periodic winds. Under periodic winds you will find land and sea bridges, right? But in majority of the sources you will find land and sea bridges, they have been kept under the secondary wind system, right? The secondary wind system. Even I logically do not find it appropriate to include here under tertiary or sub-local winds, because local winds have a local contour. They are restricted to a small area only, whereas land and sea bridges, they operate over large area, right? So keeping land and sea bridges here is not appropriate. Yes, not appropriate. As far as mountain and valley bridges are concerned, I may agree to this, that yes, you can keep this mountain and valley bridges here, so that there is a confusion in classification. Okay? But don't worry about this. You don't have to take a call here. You don't have to make a judgment, right? You just have to talk about land and sea bridges, and appropriately that can be kept under the second order, right? Or I would say the second category of wind system, or you can say the secondary wind system. Now coming to the local winds, which are in true sense, right? जिसको local winds हम कह सकते हैं. So these are your non-periodic winds, right? Local winds are non-periodic winds, which are of two category, hot and cold winds. Okay, hot and cold winds. Now what you have to keep in mind, like if you see the previous questions of UPSC, you will find that they have asked to explain the local winds, right? By some example, right? Explain what are local winds by taking some example, highlighting their characteristics. Okay, that means you have to take some example of local winds from here, either hot wind or the cold winds, right? And you have to talk about the impact generated by those hot and cold winds blowing in any particular area. So when we talk about local winds, always keep in mind that local winds are product of what? Obviously they are product of pressure gradient, right? Pressure gradient force, there is no doubt about this. That means they are product of local pressure gradient, and the second one is the peculiar topography of the region, right? When I said topography, I'm talking about the relief, I'm talking about the physical features, right? So these local winds are mainly product of local topography, or you can say local relief, right? Local relief as well as the local pressure gradient, right? The local pressure gradient. These winds are having their own importance in sense bringing changes in locals and local atmosphere. That means over a locality they are very important to bring changes. And when I say changes, that means changes in atmospheric condition, temperature, precipitation, humidity, stability, instability. These are the four things you have to talk about, right? So first thing is temperature, second thing is precipitation, number 3 is humidity, number 4 stability, right? Just talk about this, and you can include the fifth one also, that is air pressure, right? These are the 5 points you have to mention. So just try to generalize what happens to your locality if your locality is visited by hot wind, right? If hot wind comes to your locality, what will happen to temperature? Tell me. Obviously, there will be rise in temperature. What will happen to pressure? What will happen to pressure? Obviously, the pressure will decrease. Yes. Number 3. What will happen to precipitation? There are chances of precipitation because the warm wind have a tendency to rise up. Yes or no? So you have precipitation also, right? Number 4. What can be right? What can be the level of humidity? Obviously, the level of humidity would be high because of because the warm air have larger. And we have discussed it length and breadth. We don't have to talk about now the same thing, right? You just have to apply your mind. Okay, avoid reading and focus more on thinking. Okay? नहीं तो क्या होगा? You will be right. You always overburdened with the study material, and never ever never ever a time will come in your life when you would feel confident that yes, I'm ready. I don't need any assistance. I don't require any support. Okay? तो इसलिए आपको ध्यान रखना है कि जस्ट 5 बातों का ध्यान रखो. ठीक है? क्या होने वाला है? If say the place is visited by either cold wind or soft wind. ठीक है? Just 5 things: air pressure, air temperature, humidity, precipitation, and what? Stability and instability. That's it, right? Okay. Let us take for example once over wind here. I'm taking phone के बारे में देखते हैं. So obviously you should know, you should know the location of that particular wind, where it blows, right? This phone and chinook, this phone and chinook, these two winds are product of topographical factor. Topographical factor. Are you getting my point? Topographical factor. Whereas these two winds are product of atmospheric factor. Now why I'm saying this? Because this is your phone, right? You must have heard about phone. This wind blows in the European region, starting from the southern slope of Alps, and this is your Alps mountain. Okay, this is your Alps. This is the northern slope, and this is the southern slope. Okay, northern and southern slope. So this, you know the direction of the wind. This is your subtropical high pressure, right? This is your subpolar low pressure. Yes. You know the primary direction of the wind, that is westerly. Yes. These local winds are going to follow sometime they are going to follow whom? Obviously the secondary wind system. Now what is the secondary wind system here? You know the secondary wind system here is temperate cyclone. Don't forget the Mediterranean belt, right? This is one of the prominent belt for occurrence of temperate cyclone. Okay. So you have this horn. This wind blows from hot wind, blows from this southern part and then move towards the southern slope of Alps, right? और बोलने की जरूरत नहीं है क्या होगा? Southern slope of Alps. This is your southern slope of the Alps. This is your windward side. And what happens? Rest is the story. I don't have to repeat that, right? So that will lead to what? Adiabatic cooling, condensation, cloud formation, heavy precipitation. Where? On the southern slope of Alps, right? Southern slope of Alps. After setting their moisture, they descend down on the leeward side. They descend down on the leeward side. As they descend down on the leeward side, what happens? Obviously, here we have high pressure, and because the air is descending, you have high pressure here, and at some places here, that means further north, it will have low pressure. So wind blows from high pressure to low pressure. Here we are talking about phone. बात समझ में आ रहा है? अरे सुनो, we are talking about phone wind here. यहाँ पे बात कर रहे हैं. So this wind which was hot, it said which was warm, which emerged from the Mediterranean belt, moved toward the northern part. It said it got adiabatically cooled, caused precipitation in the southern part of the Alps, and then it started descending down. You already know the adiabatic heating, right? What will happen? Compression, adiabatic heating, and the air mass becomes warmer, right? The air mass becomes warmer. The rate of adiabatic heating is around 10 degrees Celsius per kilometer of descent नीचे जा रहा है. ठीक है, heating लगभग dry adiabatic heating हो रहा है क्योंकि dry air है ऊपर में, moisture नहीं है. And finally the air start descending on the northern slope of the Alps, right? Here we have development of high pressure, and further north we have low pressure. Now you have movement of wind from high pressure to low pressure. That is your one, right? This northern part of Alps is very cold, right? Very cold. Okay, you have right. You have fields cover, right? Fields having some snow cover also. You have chilling cold in the northern part, chilling cold, because you know the role of latitude. As you are going up, what will happen? You know the role of continentality. As you are going in, right, inside the continent, what will happen? Right, lower the temperature. So with the movement of this small wind, what happens? The temperature of that particular area, is क्या होगा यहाँ पे? The temperature increases. Yes, pressure decreases. What will happen then? Humidity increases. Yes or no? अरे जहाँ पे ये जा रहा है गर्म हवा, वहाँ क्या करने वाला? Obviously that will lead to what? That will lead to increasing temperature. That will bring down the pressure, right? Inverse relationship between temperature and pressure, you know that. Obviously that will increase humidity level also, because this air will be able to absorb more and more moisture. Then what will happen to precipitation? Precipitation का भी chances है. You may have some precipitation, right? May have some precipitation. But again, that depend करता है. ठीक है, क्योंकि और नॉर्थवर्ड जा रहा है तो क्या होने वाला है? Obviously you have cold condition, that there is no chance of convectional activity. Convectional activity होगा तभी ना, या तो कोई orographic barrier हो, फिर adiabatic uplifting हो सकता है, right? So this is the general behavior we have, and that brings relief to the people in the northern part of Europe. Why? Because that raises the temperature. That helps help the field to be free from frost action. It ensures spring farming. Winter के बाद spring आया, अभी भी temperature बहुत low है. It is not able to carry out agricultural activity. With the coming of this wind, what happens? The farmers are ready to carry out farming activity. ठीक है, तो ये सारा काम होता है fawn का. ये बस याद रखना है इसका. ठीक है, that helps in spring farming, that helps in ripening of the grapes, right? Ripening of the grapes, ripening also increases fastly because this is hot wind now. Okay, hot wind समझ लेना, that is in relative sense. Okay, relative sense में जहाँ पे जगह है वो cold है और जो हवा आ रहा है वो उसका temperature ज़्यादा है, तो क्या बोलेंगे आप? Obviously that would be hot wind. Yes or no? So this is how you have to deal with this. Just go for one reading. एक reading करना है, don't repeat that again. Right? Apply your mind. What will happen? Okay? Yes, right. Yes, you have to keep in mind the location of that particular wind. Right? Where it emerges. Right? Where it emerges. Right? I mean, talking about its characteristics or the impact it is generating. Right? In the visiting region, that is very easy to find out if you focus on these 5 things. Right? You can include stability or instability also. बस इतना ही फोकस करो. मेरी फ्रेंड्स, I mean, ये दोनों का वही काम है, वही चीनों भी वही करते हैं. ठीक है, that slopes down, right? That slopes down on the eastern slope of Rockies and sand, right? And that starts eating the snow. ठीक है, इसलिए इसको snow eater भी बोलते हैं. ठीक है, sublimation takes place, right? Sublimation takes place. That means the snow is directly converted into water vapor, right? Sublimation. So this is helpful again for carrying out agricultural activity. That gives relief to people from frost action, right? It increases visibility बढ़ने लगता है ना? All those things you'll find associated with these two winds. So they are topographical, right? They are product of topographical factor, mountain values, right? So in case of Chinook it is Rockies mountain, and in case of Fawn it is Alps mountain, right? The highest mountain of Europe and is the highest mountain of North America. Okay? Likewise, if we talk about these two winds, Sirocco and Harmattan, they are product of what? They are product of atmospheric phenomena. Okay? ये same जगह पे आ जाओ. This one equatorial belt. You know the equatorial belt, fine. You also know the climatic condition here. You have high temperature throughout the year. You have heavy precipitation taking place throughout the year. Yes or no? So what happens? This is your Harmattan wind, which emerges here in the Sahara belt, in the Sahara desert, and it moves toward the west की तरफ जाता है. ठीक है? What is the direction of the primary wind system? You already know, northeast. आया ना? So when this Harmattan wind blows from South Africa, blows from this Sahara desert region, that wind is what? That wind is hot, dry, अरे चलो ये wind कैसा है? Hot, dry, dusty, having high speed, dusty, okay, and is moving toward the equatorial belt. People here in the equatorial belt are suffering from extreme dampness, right? High humidity condition. When this air or wind comes in the northwestern part, or I would say the western part of Africa, what it does? क्या करने वाला है? Obviously, the dry hot wind would absorb the moisture. It is going to absorb the moisture, right? And that provides relief to the people who are suffering here from extreme high humidity condition. ठीक है? अरे ये कैसा है? Hot dry है. और ये जगह पे क्या है? You have damp condition here, right? Damp condition here. That is why this Harmattan wind is also called as doctor's wind. क्या बोलता है? Doctor's wind. Why? Why doctor's wind? Because that gives relief to the people here. Just like a doctor giving relief to pain. सुनो, जैसे हम लोग कोई बीमारी होता है डॉक्टर के पास जाते हैं, डॉक्टर हम लोग को दवाई देता है, ठीक है, और हम लोग ठीक हो जाते हैं. उसी तरह से ये डॉक्टर्स विंड है, इसको हम डॉक्टर्स विंड बोलते हैं. That gives relief to the people where the humidity level is checked, right? It absorbs moisture from the atmosphere, right? It brings relief to the people because they are suffering from intense high temperature and heavy precipitation throughout the day, throughout the year. Okay. Likewise, you find Sirocco भी एक wind है, कैसे चलता है, ठीक है? Sirocco emerges in the northern part of Africa, right, in Sahara Desert, and moves toward the Mediterranean belt, towards Italy and towards southern France. ठीक है? जैसे यहाँ से जाता है ये कैसा है? ये भी वैसा ही है, hot, dry, dusty, and dusty wind. ठीक है? जैसे ऊपर जा रहा है तो क्या होने वाला है? It is going to pick the moisture from where? Pick the moisture from Mediterranean Sea. ठीक है? It starts picking the moisture, and you have orographic barrier here in the southern part of Japan. In the southern part of France, and you have Italy. That's why I don't prefer this recording. I become so concise. So I said this is your क्या मैंने बोला? Southern part of France and Italy, and when you have orographic barrier, obviously the moisture laden wind will cool adiabatically, that will lead to precipitation, right? When we have precipitation here, the color of rainfall is orange to red. कैसा होता है? Orange to red, because these winds are what? They are lifting sediments from the surface here, which are of red color का होता है. और सेडिमेंट के साथ ये हवा जा रहा है, मॉइस्चर भी पिक कर रहा है, एंड फाइनली इट इज अंडरगोइंग कंडेंसेशन एंड यू हैव रेनफॉल. इसीलिए यहाँ पर रेनफॉल को क्या बोलते हैं? इन द साउदर्न पार्ट ऑफ इटली इट इज कॉल्ड एज ब्लड रेन. क्या बोलते हैं? ब्लड रेन. ठीक है? नॉर्मली हम लोग को रेनफॉल होता है तो कैसा? पानी ऑल ओवर ट्रांसपेरेंट, इज नो कलर, बट यू फाइंड कलर ऑफ द वाटर हियर just because of the dust, right? The color of the dust which is carried by, which is deflected by the wind here from Sahara Desert towards the southern part of Europe, especially in Italy and southern part of France. ठीक है? ये this is your Sirocco. तो ये सब आपको देखना, just go for one reading and see what happens, right? What happens when a place is visited by the hot wind or shore, maybe by the cold wind. Okay? These are the basic things you have to do. I mean, just go for one reading to understand wherever you find such winds, right? Just the locality of their occurrence. That's it. Right? Once you know this, you just apply your mind and focus only on these 4-5 parameters. You would be getting 4-5 points. That is more than enough, right? You would be able to write about one local wind in one paragraph, right? If you have taken two local wind. Right, that means you will be writing 2 paragraphs, which also means that you will be writing around 100 words. Okay, one paragraph मतलब 50 words on an average, right? Yes or no? तो अगर आपने 3-4 उठा लिए तो आपका मालूम है, you will be crossing the word limit, है ना? So you have to be careful here. You have to talk about the local wind, how the local winds are generated. Don't forget any type of wind, global, right, or secondary or tertiary wind, all those winds are product of pressure gradient force, right? ठीक है, उसको तो आप नहीं बोल सकते, yes or no, right? So this is I mean, this is how you have to deal with this chapter of local wind. So that completes the wind system, and now we are ready for the last part of climatology, and obviously we are into the last part of this session. That means the session before the break for election. Next chapter, or I would say the last chapter of climatology, that means in sequence. We have some minor topics also, but this is a sequence where we have to understand different schemes of climatic classification proposed by scholars like Open, Convoy, and Freewater. These three classifications have been included in the syllabus of climatology. So there is the classification of climate. Okay. So to understand the classification, the basis of the classification, first of all we have to understand what is a climatic region, right? What is a climatic region? And to understand a climatic region, first of all we have to understand the difference between weather and climate. Okay? Weather and climate. I'll just take 5 minutes to explain this. Whether you all know, I mean, majority of you must know weather. जैसे हम बोलते हैं ना, day to day parlance what we do. I mean, हम लोग जैसे आज बात करें तो आप क्या बोलेंगे? सर आज का क्लाइमेट कैसा है? ऐसा बोलेंगे क्या बोलेंगे? हाँ, जवाब मिल गया, ठीक है? तो हम क्या बोलते हैं? डे टू डे करके से बोलते हैं आज कैसा वेदर है? ये तो नहीं बोलते ना आज कैसा क्लाइमेट है? यस, हाँ, है ना? या आपको कहीं जाना है तो आप फोन करते हैं और आज का मौसम कैसा चल रहा है? मौसम ठीक ठाक है? कपड़ा कौन सा लेके आओ, विंटर वाला या समर वाला? 109. तो वेदर इज व्हाट? वेदर इज ए शॉर्ट टर्म phenomena, whereas climate is aggregation of that short term phenomena in a long term, right? In a long term. So weather talks about day to day behavior of the fundamental elements of climate. What are the fundamental elements of climate? Temperature, precipitation, altitude, latitude, and yes or no? These are the fund air masses, right? Wind speed, all those things are your fundamental elements. Among the important elements of climate, the most important elements are two, that is temperature and precipitation. Okay. Among these two, the most important one is precipitation. Okay. Because precipitation directly controls the behavior of natural vegetation, right? Whether the vegetation will have stress of moisture or it will have no stress of moisture will depend upon the availability of moisture. Okay, so moisture becomes the most important element, because we also know that the climate of any particular place is mirrored image of natural vegetation of that particular place, right? Are you getting my point? So this is your weather, which talks about day-to-day observation of those fundamental elements of climate or fundamental elements of atmosphere, whereas climate deals with long-term phenomena, right? Long-term phenomena. Weather is subject to what? Weather is subject to day-to-day changes taking place in different seasons, but climate does not go under day-to-day changes. You have long-term changes here. I mean to say, if if you have if you have been to this place right from the birth, you must have seen in last 20-30 years how the climate has responded. So no, the climate of your place has undergone change, but that observation can be made only after 10, 20, 30 years. Yes, 10, 20, 30 years. I mean to say, go back in time 20 years back. Okay, the summers used to be shorter and the summers used to be mild. Yes. Now what you find? You find summers summers of longer duration, and then they are becoming more and more intense. There's one observation you must have made, right? So that is about what? That is about the changing behavior of climate of your particular place. Okay. So weather deals with that, the weather deals with day-to-day observation, day-to-day behavior of those elements of climate, whereas climate deals with the average of such variation, right? Average over a long period of time, maybe 20, 30, 40 years, right? You can take that, you can take that average for maybe million years also, okay, million years, right? Like when we talk about the Earth, right? Earth as a system, right? When you talk about the Earth system, you know that Earth has been subjected to glaciation, right? Earth has been subjected to glaciation in the recent time, and that was around 1 to 2 billion years ago, right? 1 to 2 billion years ago. That was the age of Pleistocene era, right? So Earth underwent glaciation. So then in that case, what we can say about the Earth, during that period of time, you would say that the climate of the Earth in between 1 to 2 million years ago was very, very cold. So now we are living in the warmer phase of the Earth. So what we can say about the Earth? We can say that Earth is warmer now. Earth is having warmer climate at any point. So that warmer or colder characteristics of this Earth is about the average of those warmer and colder conditions taking place in different parts of the world, right? Yes or no? I mean to say, let's say when you have colder conditions across the whole globe, it doesn't mean that everywhere you have colder conditions, right? When you have warmer conditions, when we say that Earth is warm now, it doesn't mean that you have warm conditions prevailing everywhere. Go to the polar area, what do you find? You find permafrost conditions. You find very low temperature condition. Go to high altitudinal zone. What do you find? Very low temperature condition. Yes or no? So this is mainly about the average. It is talking about the average, and it is talking about the real changes taking place in the elements of weather, or you can say the elements of climatic phenomena. Okay. So based on this, we can define what is a climate region. So what is a climate region or a climatic region? It may be defined as a portion on the surface of the any particular area. Okay, a portion on the surface of the earth, portion on the earth surface over which the important elements of climate. Important elements. What are the important elements? I have given you some example here: temperature, precipitation, humidity, right? Over which the important elements of climate and their broad characteristics, right? That means the behavior, right? The behavior of temperature, precipitation, or humidity, right? The behavior of these important elements of climate remains similar, right? Remains similar. So you can say that in simple sense, a climatic region is a region where you have homogeneous behavior of the fundamental elements of climate, right? What are the fundamental elements? What